All right, so we left off talking about the median, and I talked about how there's different there's sort of two different ways to find it depends on how many data values you have. But then I said that if you use your calculator took care of those things. The mean involved every single data value. You had to add all of them together and to divide by how many you had. Again, all you have to do is put it on your table, on your calculator, and you go to stat calc 1 var, and then here you can make sure that one's cleared. You can actually find your mean that way. You can also find your median that way as well. And don't forget to sort of leave this screen. If clear doesn't get you out, you hit second and then quit. Gets you back to your home screen. But the median is looking at the middle value. And you always want to write your list from in increasing form. So if you notice here, the numbers are increasing. So from smallest to biggest is normally how you want to arrange your data set. And then there's these two different ways. So here, the two different ways of how to find your median. And the difference is if you have an odd number of data values or if you have an even number of data values. But using your calculator, you don't have to worry about that at all. Because if we look at this data set here. So the similar data set in the previous problem. So if we look here, try to compare both. It's kind of hard to get both of these in focus. See if we'll focus both. There a little bit. So we have 38.5, 55.6, 24.4, 14.8, and 23.1. So all the exact same ones. Again, and I don't have to worry about trying to list them in order and trying to find the middle one. So here again, we know the median is 23.1. All I have to go here, remember where you put your data. You put it under L sub 1, which is right up here. To be able to get that, you need to use the blue one. To get the green ones, you use alpha. So remember, what class is this? It's a stat class. So you would hit stat, and then you go to the right ones to calc. And on 1 var, you can either press the number 1 or hit enter. They'll both take you to the same place. So look, I'm going to press 1. Put me right here. I'm going to hit stat, calculate, or I can press enter, same location. But if we zoom in, the list is looking at is L sub 2. But I don't want to use L sub 2. I'm looking to use L sub 1. So I'm going to hit second and then 1. And that gives me L sub 1 that I need. And for the frequency list, it's going to be blank. We're going to use that in a little bit for something called the weighted mean. But we're not there just yet. And then you just hit enter on calculate. And if you scroll down, there's a bunch of information it gives you. And I'm going to post the exam up today on Friday. And it'll be due Saturday night. No exact time. Just try to get it to me by Saturday night. And I'm going to be asking for some of this information. I'm going to be asking you to give me the min value, this Q sub 1, this median, Q sub 3, and this max. Again, we haven't talked about what the Q sub 1 and Q sub 3 mean. But since you already get all this information by just doing 1 var, I'm going to ask you to put that on the exam. So just keep note of that. But if you look at right there at the bottom, there's the median. 23.1. Let's see if it zooms in. 23.1. If it focuses, 23.1. And then this is the second case. So if you look at now, we have, I'm going to put stat. So stat. And then enter on edit. And then we have the 38 already. We have the 55.6. We have the 24.4, 14.3. 14.1 and 23.1. Those are all values we already have. See if I can get this to focus. So we have that 38.5, 55.6, 22.4, 14.1, 23. But then it's giving this additional value, this 24.5. So again, 24.5. And then I have to hit enter. Again, if you accidentally press something wrong, you can just go and hit delete, right hover over it. If you want to get rid of the entire list, you can go up here. Don't hit delete, because if you hit delete, you're going to erase the whole entire column. All you have to do is hit clear. So when you go up there, it shows all the numbers in that list. You can hit clear, and then you hit enter, and now erase everything there, but it won't get rid of the column. So, but if you just want to get rid of an individual one, all you have to go is hover over it and go to delete. So let's add that value. What was it? 24.5. You guys gonna see here 24.5. Then it's gonna enter. What that is doing is now it's giving us an even number of data values. And there's something you have to do slightly different, but with your calculator, you don't have to worry about that. Look, there's all this information it's asking you to do. List them from least to greatest, but like, I'm not listing anything. I just included it. And then I'm going to go stat, calc again, one var. You either hit 1 or enter. The list is still on 1. Right, if I go back, look, stat, hit enter. My list is still under L sub 1. So I'm going to hit stat, go over to calc. Hit enter on one var, and then go to calculate and hit enter. And you scroll down, there's the median. It's 23.8 and 23.8. So again, if you guys want to do it by hand, you can, but your calculator does it all for you already. So keep that in mind. All right, now that's how you get your median and your mean and your median. Well, the mean was in the previous video, but something I skipped for both of these, it was early on. So I showed you what these notations were and all these, how one means sum, X represents your variable, N is your sample size, and then capital N is the size of your population. I skipped this idea here about being resistant. So the idea of being resistant is that when you're calculating your average or your most common data value, that it's not affected by very large numbers or very small numbers. And those very large numbers and very small numbers are called outliers. So those you want to be careful for. So the idea of your average being resistant is saying that it's not affected by really large numbers or really small numbers. So the mean is not resistant. Because if we look at this, if I just try to find a random, mean, so let's do this. So I'm going to input a bunch of numbers here. Just to keep it small. Let's do 1, 2, 3, 4, 5, 6, 7, 8. And that's under L sub 2. And then let me calculate my mean. So again, stat, go to calc, one var. I can just hit the number 1. It'll take me there. But remember, my list that I was looking at is under L sub 2. So I need to hit, to change it, I need to hit second. L sub 2, go down to calculate, and then enter. So if we look at our mean, it's 4.5. And that makes sense because all our numbers are relatively close. So having our mean being 4.5 makes sense because majority of our values are pretty close to 4.5. But this is what I mean by your mean is not resistant. Because watch me put 100. So that's definitely nowhere near where the rest of these numbers are. So if you hit stat, go to calc, one var again, same list, you calculate it, and then look at our mean now. Our mean went to 15.1. But if you go back to your list, none of these numbers majority of them are nowhere near 15. So 1 isn't close to 15, and then 15 isn't close to 100. And that's the problem with the mean, because it takes all the data values into account. Imagine this was 1,000. Let's put 1,000 here. And I do the same thing again. Stat, calc, 1 var, calculate. Now it's telling my mean is 115. So if I go to my list, now definitely none of these numbers here are close to 115. 1,000 is also not even close to 115. So that's the problem with the mean. It's not resistant, because very large numbers or very small numbers affect the mean dramatically. But the median, on the other hand, since the median is technically writing your writers from smallest to greatest, that very, very large number will be on the far right, or that very, very small number will be on the far left. The middle is still going to stay roughly the same. So this is where it says the median does not change by large amounts when we include just a few extreme values. So the median is resistant measure of center. And we can see that, because if we actually go back to this data set and I go to calc and then 1 var, same list. If you look down, our median is 5. And when we didn't have the 1,000 or the 100, our mean was 4.5. And that made sense, because the majority of our data values are pretty close to 4.5. And our median is still 5. That 1,000 did not affect it whatsoever. Look, I can even put a much larger number. Let's put 5,423. Something crazy. I go to stat, calc, 1 var again. Go to calculate. And look at our mean. Our mean is now 606, which none of our data values are near that. But our median, still 5. So we look again. Our median is still 5. And that's the idea of resistance, is that very large or very small numbers do not affect it whatsoever. The mean is affected by very large numbers or very small numbers, where the median is not. Just because the very large or very small numbers will be either on the far left or on the far right, not affecting it whatsoever. So that's a nice thing about the median. You want to be thoughtful on when to use this. For example, the one that I always said about trying to calculate the average height of PCC students. And basketball players are also PCC students. So using the mean might not be the best form of calculating the average height of a PCC student if a few of those heights are extremely large. So the median might be a better way of calculating the average height of PCC students, because it would look for in the middle, where depending on how many heights you have, the median might be the better way to go, just because it's not affected by very large or very small numbers. And the notation for a median, you might see just mid, or how you see here, mid, that implies median on your calculator, or just a capital M, just some notation to keep in mind. Again, this idea of the odd and even numbers is if you're calculating it by hand, but like I said, just use your calculator and it's gonna do that for you every time. You don't have to worry about if there's an odd or even number of data values, just for the sake of time. Now, here's our third way of being able to calculate the measure of center, and which is the mode. And I'm sure you guys, some of you might remember the mode, and the mode has to do with the data value that appears the most. So the mode of a data set is the value that occurs with the greatest frequency. So that means how many times it appears. The nice thing about our mode is that when we're looking at the mean and the median, that is for quantitative data values. You can't add up like names and labels, because those are qualitative variables. Same thing with median. I can't list someone's name from least to greatest. I can do an alphabetical order, but again, I can't input names into my list and have my calculator calculate it for me. So the mean and the median are strictly for quantitative data values, where the mode is actually for qualitative and quantitative. Because the mode is just looking for which data value appears the most. And sometimes there's more than one mode. Sometimes there isn't any modes. And then we'll see some examples of that. But just keep that in mind. The mode is also very useful because it takes care of qualitative data for us. Where the mean, the median, and we're going to look at the mid-range soon, only looks at quantitative data values. So the example of the police officer or the officer trying to find the most common manufacturer in the college parking lot, he had to use the mode, which is just which manufacturer showed up the most amount of times. Did some show up the same amount of times? Meaning there might be 2 modes, there might be 3 modes, or there might be no mode. Maybe everybody showed up the equal amount of times. So for there to be a mode, there definitely has to appear more than once. But it also has to appear the most number of times. But if 2 values appear more than once, but the same number of times, that makes them both the mode. And here, let's actually look at an example. So this is what I mean by there could be multiple modes or no modes. Sorry about that. So for example, here, you can definitely see 0.1 only appears once. Here, even though 0.6 appeared more than once, it didn't appear more times than 0.3. Hence why 0.3 is our mode, because that one appeared more than once and it appeared the most number of times. So you want to be careful. Now here's an example of 2 modes. So here, 0.3 appeared more than once and it appeared twice. 0.6 is only once, so that cannot be a mode. But 0.4 showed up more than once and it showed up twice. So 0.3 and 0.4 both appeared more than once and appeared the exact same number of times. So both of them are considered the mode. When the next example, none of these appeared more than once, so there can be no mode. So again, there's 2 things. It has to appear more than once and it has to appear the most number of times. But there's a possibility of numbers appearing more than once the same number of times. So here, this appeared more than once, this one appeared more than once, and they both appeared the same number of times twice. Hence, they are both the mode. And that's the nice thing about the mode. Again, it's not... you can still do this with numbers. You could have also done this with qualitative variables. You can see a list of names. Like the officer in the college parking lot could see 30 Toyotas, 2 Ferraris, 40 Fords, and 20 Nissans, and so on and so forth. And you're just looking at which one appears the most number of times. He's not calculating or adding anything. He's just counting how many appeared in the college parking lot. So that's a nice thing about our mode when you're doing this. So keep that in mind. And then here's our the most basic way of trying to measure this center. And by the idea of measuring the center, the concept of the middle is thinking that the majority of your data values are somewhere in the middle. And that's where the mean comes in. It's trying to calculate the middle, which should be the most common because that's where the majority of our data values are, in the middle. The median, again, it looks for the number exactly in the middle. By listing them from smallest to greatest in increasing form. The mode, again, doesn't find the middle, but it's not about like trying to find the exact middle, but it's looking for the one that appears the most number of times. So that would be the most common one. As we think of what most common means, is the one that shows up the most number of times. Now the mid-range is just finding the middle. So it's taking the largest value. So you see here, the largest value, adding with the smallest value, and then dividing by 2 in hope to give you exactly the middle of your data set. So don't get that mixed up with the median. The median lists them from smallest to greatest, and then it tries to look for the middle after that. This just takes the biggest and the smallest, adds them together, and divides by 2. So don't get that confused with the median. There's 2 completely different processes to do that. And plus, the median we'll do on our calculator. The mid-range, you just take the largest plus the smallest, and you add them together. So, see an example of that. So, another idea that the issue with the mid-range is that it's also not resistant like the mean. Because if it takes the largest and the smallest, if you're looking at our data set, so again, stat, enter. If you look at this data set, that means it'll take 5,423 plus 1 and then divide by 2. Where our median, so let's try to look at what that would be. So 4223. So, what did I say it was? I forgot. 4223. 4223. I'm tripping. Let me do that again. Sorry, guys. 5423. I think I'm a little dyslexic. 5423. So 5423 plus 1. So you want to be careful when you're adding these. Because if I put divide by 2 right now, what it's actually doing, it's going to divide the 1 and then it's going to add it with 2. If you wanted to add these 2 first, you have to put parentheses around them. So 5423 plus 1. And then in parentheses, that's telling us it wants to add these first and then divide by 2. So it's really important you get to learn how to use these to create grouping symbols. And that gives us our mid-range here would be 2,712. But if I try to calculate the median here, our median is still 5 because the median is resistant. It's not affected by large or small numbers, where the mid-range is affected by, the mid-range is affected by very large or very small numbers because it's literally using the largest and the smallest number. So those two, there could be outliers, and it's not going to help you. It's going to give you the middle from the biggest to the smallest, but might not give you the most common one, where the median is resistant because it's not affected by those. So you see the 2 differences between the mid-range and the median. They both give you a middle, but one gives you the median. The median gives you a more accurate middle of the most common data value, where the mid-range just gives you the middle of 2 data values that might not necessarily be where majority of your data values lie in to begin with. But the nice thing about it is easy. Just take the biggest and smallest, add them together, and divide by 2. Again, and then there's just so you guys can see, there's more ways to help you define the mid-range, try to find the center. But again, you need to start thinking about which one is the best method of calculating the center. One big thing is, are you dealing with qualitative or quantitative? Because if you're dealing with qualitative, that automatically takes mid-range, median, and mean out of the picture, and you only have mode. But if you're dealing with quantitative, now you have all of these to work with, and you want to decide, like, are there outliers? Or do you suspect there might be outliers in your data set? So maybe I want to use the median. If I don't expect there to be outliers, then maybe I want to use the mean or the mid-range. And so just keep that in mind. There's different ways to approach this. And then the mid-range is not the same. The median is not the same thing as the mid-range, as we just showed using our calculator. So keep that in mind. So here, from this data set that we're doing, we just take the largest and the smallest and divide by 2, which that gives us 34.8, which that wasn't necessarily the median. So if we go back here, edit. So here's that data set. I think minus that 24.5. Let me delete that. And then everything else should be the same. 38.5, 55.6, 24.4, 14.1, and 23.1. So I go to stat, calc, 1 var. Again, I could just press 1. And then again, I have to change the fact that this is at L sub 2. My data says in L sub 1. So I hit second, then L sub 1, because there's my L sub 1. Then I go down to calculate. I hit enter. And my median is 23.1, where here the mid-range is 34.8. So definitely not the same thing, because the median is listing these from least to greatest, and this is just taking the biggest and smallest and adding and dividing by 2. So slight differences in their calculations, and you can see slight differences in their outcome. So really important that you watch out for that. And again, depending on what you're trying to do, one way might be more beneficial than the other. So it's just good to know all these different ways to be able to calculate this. Sorry for moving. I keep kicking the tripod that I bought on Amazon. It's cool because I already had it from like making my videos for my bus. So I'm glad I had this already. I had to order it. But I keep kicking it for some reason. All right. Just something to reiterate. Don't forget, zip codes, license plate numbers, IDs, your social security number. All these are numbers, but all these numbers represent qualitative variables. So don't try to get a bunch of zip codes and try to find the mean or the median or the mid-range, because you can't. Because these values don't have a numerical value. Like they don't actually have a numerical measurement. They represent labels, names, categories. So just to reiterate, when we played our Survivor game, these numbers are not quantitative. They're qualitative variables. So don't try to calculate anything with them. You can use the mode, because the mode is good for qualitative variables, but you cannot use the mean, the median, or the mid-range. Same thing here. Rankings from, like when we talked about food, or you're talking about sports teams. Though these rankings are not a numerical measurement, it's more of a quality. It's measuring the quality of something, which you cannot try to calculate using the mean, median, or mode. So just don't forget about that. The mean, median, and mid-range are for quantitative variables. The mode is the only one for qualitative, and it can also do quantitative. So that doesn't mean the mode is the best way to calculate, since it does all of them. The mean is sometimes the median is great for when you're dealing with outliers, and so on and so forth. So keep that in mind. Now, let's say that all these other, that we mid-range, mode, median, all of these are if you actually have the data set. What if you're looking online and you don't have a data set? All you do is you have your frequency table. Then with this frequency table, you have to try to figure out what is the meaning of this set, because all these are quantitative variables. We can see that because this is talking about a time in seconds. So between 75 and, I'm getting tongue twisted, 75 and 124 seconds, 125 to 174, 175 to 224 seconds. That is definitely quantitative. So that means I'm either going to use mean, median, or mid-range. But to be able to use the mean, I need a data set. All this is telling me that 11 data values fell within 75 to 124 seconds. Saying that 24 data values fell within 125 and 174 seconds. Whatever that may mean. Maybe people are trying to hold their breath underwater, or people trying to guess what a minute is. Whatever the study was, that's how many they did. 50 frequencies. That means that's the size, their sample size. That's how many data values they have. That's the total number of frequencies. Remember, that symbol just means sum. So all you're doing is adding all these frequencies together. So this idea here of calculating the mean from a frequency distribution is if you don't have the actual data set, you don't have the numbers, meaning there's no way you're going to be able to put them in your list. There's nothing to put in here. If I give you this, you have nothing to plug into your actual list in your table. So that means you need to figure out, how can I calculate the mean using my frequency table? And this is the formula. So again, here's the symbol of mean. Remember that bar? We go back to the beginning. Here, that means the mean. This X bar represents the mean. So let's go back here. So we're trying to calculate the mean. And the way you do that is you have to add. Remember, this means sum. You have to add some products. And we'll talk about what these products are. Divided by the sum of frequencies. So if we look at this, our total number of frequencies are 50. So that means we're going to end up eventually dividing something by 50. But to do that, I need to use the frequencies and multiply it by this X. What this X means, if I look at my table, it's talking about the class midpoint. What the class midpoint is, you have to take the smallest, you have to take this is the lower bound and the upper bound, and you have to add them together. So we see this really quick. So I'm going to take 75, add it with 124, and then divide. Since we're adding two numbers, we're going to divide by 2. So if I look here, our data set, so second quit to get out of here, I'm going to do 75 plus 124. That gives me 199 for the numerator. $199. Now to divide that by 2. So I'm going to bring this into view. I'm going to divide by 2. Enter. Gives me 99.5. And if we see, that's our 99.5 there. And that's what this whole column is doing. It's adding 125 plus 174, dividing by 2, you get 149.5. And the idea is you take the lower limit. Sorry, it's kind of like seeping through. You take the lower limit plus the upper limit and divide by 2. What is the upper and lower limit? That's these. These are all lower limits. These are all upper limits. So one more time. These are all your lower limits. These are all your upper limits. But you're not going to add the lower limit of one row with another upper limit of another row. You have to stay within the same row. So I did 75 plus 124, and I divided it by 2, gave me 99.5. You're going to do 125 plus 174, divide by 2, and that'll give you 149.5. And you do that for every single column. So then you find the class midpoint of each single one, and that's what that X ends up representing. It ends up representing your class midpoint. Then you take this number and you multiply it by the number of frequencies. So that's what that F is your frequency. And you multiply it by your class midpoint. So if we had, let me see here. So we have 99.5. So we put 99.5. Now I'm going to multiply with however many frequencies were in there, which is 11. I hit enter. That gives me 1094.5. That's exactly what I hear, 1099.5. Same thing here. You take 149.5. You multiply by how many frequencies were there. There was 24. Oh, I put plus. That's right. Multiplication. We hit enter. 3,588. Again, you multiply these together, you multiply these together, you multiply these together, and that's what this column represents. Then you have to add all those together. That's why when you looked up at this previous one, it's adding all the products. And those products are the midpoints times the frequencies. And you're multiplying straight across. And that's where these values come in. And then you want to add all of them together. So that's what it means. Add them all together. Then add all your frequencies together. We already know how to add all our frequencies. That's 50. So that means I'm going to take these two numbers and I'm going to divide them to give me my mean. And again, this is just only approximation of this because we don't actually have the list of numbers to try to plug into my table. So I have nothing to plug in here. So I have to try to use this information to help me do that. So let's take that number, that 8,000. Let me do it right here. 8,025 divided by now the 50. So I'm going to put 50. Oops, I put 5 point. I put 50. Enter. And I have 160.5. So that means 160.5 seconds. That was the most common data value. It was 160.5 seconds. Again, this is only an approximation. We don't know what the list is because we don't have the actual data set. This is just an approximation from, I know there was 11 that were in here. There might have been an 80. There might have been a 120. There might have been an 81. There might have been a 97. There was a bunch. Again, there's 24 in here. It could be a 126, a 132, a 160, a 171, a 152, a 138. There's 24 data values in here. I just don't know what they are. I'm just trying to approximate them. So that's how we can find the mean using a frequency table. So keep that in mind. Again, replay this video over and over again. And then I'll give you guys some homework to see if you guys can try practicing on that. This is going to be on the test today. So let me go through it one more time. These are your lower limits. These are your upper limits. To find your class midpoint, you want to take the lower limit, add it with the upper limit, and then divide by 2. And that's how you get all these numbers. You then multiply the frequencies in that row with that class and multiply it by the midpoint. And you do that for each single one. And you add all of them together. And then whatever total you have, you divide it by the total number of frequencies you have. And that's what this formula is telling us. Add all the products, divide by how many frequencies you had, which were 50. And again, this is only an approximation based using the class midpoints. And instead of using the original values from the list, which we don't have those. So keep that in mind when you're doing these. And lastly, something called the weighted mean, which you can also use your calculator. And I'm going to show you right now how you can do that. And what the weighted mean represents is that sometimes you're trying to calculate a mean, but the things that you're adding together don't hold the same value or the same like potency. Let me show you what I mean with an example. We all know that when we're looking at our grades, when you're calculating your GPA, there's a big difference between the person who took a math class and a PE class. If you get an A in a math class, let's say if you get an A in Stat 50, it's not the same thing as getting an A in a PE class. one's going to help your GPA a lot more than the other. Just because you get an A in your PE class and you get a C in your math class doesn't mean the A from the PE class is going to really help you. Because usually, PE classes or workout classes are usually only worth 1 unit, where this stat class is worth 4. There's some math classes that are worth 5 units. So there's a big difference between getting an A in a math class than there is in a workout class. And that's just how the things work. So when you're calculating your overall GPA, you have to take that into account. So let's look at this example. Let's say someone got an A by 3 credits, let's say a 3-unit class. And then they got an A in a 4-unit class, a B in a 3-unit class, a C in a 3-unit class, and a fail in a 1-unit class. And we know if you fail 1-unit class, it does hurt your GPA, but it's not the same thing as failing a 4-unit class. That's going to have a bigger impact on your GPA. So let's just say we're in a A means 4, B is 3, C means 2, D means 1, F means 0. And these are just the units that class was worth. So there's a formula to help you calculate the weighted mean. But I'm going to show you how you can do it on your calculator. Just so we don't spend too much time trying to do hand calculations, we can go to Stat. And then you have to enter all these into your calculator. I had already entered some of them. So these represent the units that you took. So let me put them in here. And this will represent the grade. So in this 3-unit class, you got an A. And we're saying the A is worth 4 points. So I'm going to put 4. Enter. And then in the next class, you also got another A in a 4-unit class. But we're going to still look at A represents 4. But then here you can see the units. The first class, you got an A in a 3-unit course, and then you got an A in a 4-unit course. So A in a 3-unit, A in a 4-unit. So you guys can see. And then the next is a 3-unit class, and you got a B. Don't get them mixed up. This 3 comes from the unit, but the next 3 comes because you got a B in a 3-unit class. It's like getting an A in a 4-unit class. A means 4, but there's also a 4-unit course. So we're going to use 3, but this 3 is because you got a B in the class, not because of the number of units the class is worth. And then you got a C in a 3-unit class, and the C represents 2. So 2. And then you got a fail in a 1-unit class, which means 0. So I'm going to put 0, enter. And just don't forget, these represent your weights. No, sorry. This represents your weights. L sub 3 represents your weights, where L sub 4 represents the grade you got in the class. This is how many units. And that's why the units are the weights, because you can get A's in a 3, 4, 2, 1 unit course. You can get an A in a non-credited course. So this stays the same. You can always get A, B, C, D, fail. Those don't change. What changes is how many units the class is. Next semester, when you guys take classes, some of you might get straight A's. You might get B's or C's. That type of grading has not changed, where how many units the class is worth, that is going to change. You might take a 3-unit class next semester. You might take a 4-unit or a 5-unit class. Who knows? That is what's changing. So now, let's go back to our table. I went back. I paused the video for a second. So again, weights, because these are units, grades. So this is just going to be when we look at our formula. So by W is our weights, and this X is our grades. So we have to multiply all the weights with the grade and divide by the total number of weights. Or you can just plug in your weights here, your grades here, and then go to the same place we've been going to. This is a stat class. I'll hit stat. Go to calc, 1 var, and then here we're gonna using this frequency list. So here we have to put our grades, the grades that we got. So the grades, we remember, are under L sub 4. So I'm gonna go to stat, calc 1 var, not 2 var. So my grades are on L sub 4, where my weights, meaning the units I took, are on L sub 3. So I'm gonna put my grades, the units or the weights here. And then you'll have your GPA is 3.07. And that's exactly what they did. So again, our weights, which is our units, and then this is our X, which is the grades that we got. And we can see that in our data, in our table. So see how they have a 44320. We have 44320. They have 34331. 34331. Again, you want to make sure they match up with each other. You don't want to put the A in the 1 unit course or the fail in the 4 unit. You want to make sure whatever class you were taking, you want to give that exact same grade. Here on the slides, they actually do it all by hand, where what we did is this is our grades, this is our weights. We go to stat, calc, 1 var. So remember, our grades go under our list. Our weights are our frequency list. And then when you go to calculate, you get the same answer. Nothing's changed. 3.07. So again, this is just how to calculate your GPA. On the homework, there'll be some examples. The main thing to remember, stat, calc, 1 var. Put your grades here. Put your weights here on the second one. By weights, I mean the units or the credits of the course, because that's what's changing. And then the grades always go. And just remember where you put those numbers. You might have to put L sub 1 here, L sub 2, or L sub 2 and L sub 1. What's important is the units go here, the grades, the list of grades go there. And then once you calculate, you'll have your weighted mean, which will calculate your GPA. But you never say you have a 3.07 GPA. If you think about high school, you might have graduated 3.2, 3.1, 2.9, 2.7. You've never said, I have a 3.023 GPA. It's usually the 1st place and the 10th place of a number. 1.2, a 2.7, 2.8, 3.2, 3.5, 4.0, and that's it. There's no more than the 1's place. There's no more than 1 decimal place. So you wouldn't say 3.7. You would round up to 3.1 in case you get those situations. You want to round it to those numbers. So keep that in mind. Hopefully that made sense. Let me give you some homework. Give me 1 second. And here's your homework. So this won't be due to next week. Again, this will be on your test. So if you want to use these examples to help you do the exam or just replaying the video, that should help. So the exam, I'll post it up later. I'll email it to you later today. So make sure you check your emails. And it'll be due sometime tomorrow night with the homework. And just make sure when you email on your test, try to print out the test, do the exam, take a picture of it. If you can convert the picture to PDF and then email it to me, that'd be great. If you can't print it out, do it on a sheet of paper. Also take a picture, convert it to PDF and email it to me. Just under the subject line, make sure you put exam, and same thing with homework. Just turn it in sometime next week. Take pictures of it, convert it on PDF. Just on the subject line, make sure you put that it's homework. All right, thank you.